We're now going to move on to permutations with non-distinct items, which means that we have something that is repeating. So with this in mind, let's go ahead and take a look. The formula is given to us at the top, and guess what? That formula is also given to you on your pink sheet, so hopefully you still have that at home. But it means that things are not distinct, right? So we've got something that repeats. So k different things that repeat. So notice how there's that k down there, that's what it represents. N sub 1 is the number of the first type, N sub 2 is the number of the second type, etc. So if we were talking about maybe like letters that repeat in your name, with my last name being like Hill, I only have one letter that repeats, and like that L would represent the number 2, because that's how many times L is repeated. Repetition is not allowed. So even though we've got multiple objects, we cannot use that object more than once. And order is important. So if we're talking about how many different vertical flag arrangements there are of 10 flags, if 5 are white, 3 are blue, and 2 are red. So the total number of objects here is that 10. So they're saying, if you look at the formula above, we're going to do 10 factorial on the top. As we think about those duplicates, though, there are how many different ways to rearrange these white flags? Well, technically, if you think about the white flags, think that there's 5 ways you could put the first one up, 4 ways for the next one, 3 different flags you could choose for the third one, etc. So there are 5 factorial different ways we can rearrange that white flag. So that is why we're dividing by that 5 factorial, to kind of take away those duplicates. The blue is represented by 3 factorial. Because there are, and 3 factorial equals 6, there's 6 different ways to rearrange those 3 blue flags. So therefore we divide by 3 factorial, and finally there are 2 red flags, so we also divide by that 2 factorial. So in essence, we're taking all the different arrangements, but if you wanted just to think about it in a smaller sense, like let's say we just had 2 blue and a red. You could do like blue, blue, red, but if this is blue flag 1 and blue flag 2, you could really switch those flags, and do you agree that those look the same? They're both 2 blue flags and then a red. So that's what we did by dividing by those factorials, is take away those combinations that look the same. All right, let's pull out our calculators, everyone. So we've got the calculator. Same steps as last time. We're going to, turn it on, and we're going to hit math. Remember, we go right to probability. And we're going down to number 4 for factorial. Oops, I guess I should have typed in the number 10 first. Sorry. Insert the number 10. And we're going to do 10 factorial divided by 5 factorial. And you'll still have to go over to math and enter in that factorial. We've got 3 factorial. And then we've got 2 factorial. I did put that whole bottom part in parentheses, because if you don't have it in parentheses, you will likely end up multiplying by that 3 factorial and 2 factorial. Okay, so we end up with a total of 2,520 different ways. So this is equal to 2,520. 2,520. Okay, let's look at the next one. So how many distinct arrangements can be formed from the letters of statistics? I would go through and okay, how many letters are there? As you count it up, you will realize that there are 10 letters. So once again, Rn equals 10. 10 factorial is the number on top. But there are some repeats. So if you look at the letter S, it appears 3 times. So what does that mean we divide by? 3 factorial. As you look at the word T, that appears 3 times as well. We divide by another 3 factorial. As you look at the A, it only appears once. You can divide by 1 factorial, but that's 1, so does that really matter? No, we're just talking about things that repeat. Okay, I've got an I now. I happens twice, so I do need to divide by a 2 factorial. And then I've got a C, and that only happens once, so you don't need to divide by that either. At this stage, take a moment and type that in your calculator. You should end up with 50,400 arrangements. Okay, so now's the fun part, kind of bringing things back together. We've talked about probability as being the number of ways our events can occur out of the total possible outcomes. But now we're going to combine that idea with maybe some combinations or permutations that we've seen in this chapter. So, a management pool training seminar in a company is required for selecting five individuals randomly from a pool of 7 assistants, and 5 administrators. What's the probability that all will be administrative assistants? So, if we want everyone to be an administrative assistant, we're saying out of the 5 people we choose, and we don't really care the order, so we're talking about combination or permutation. If order doesn't matter, we're talking about combination. We're saying, okay, well, there's really 9 that are possible to choose from. So I do 9, choose 5. We end up with a total of, give me one sec here. You can type it in on your calculator. We end up with a total of 126 different options that all are administrative assistants. So then we'll take those 126 that are administrative assistants. That's how many ways we can get those all administratives. And then we're talking about the possible outcomes. So there really is a total of 9 plus 5 is 14 people, and we are choosing 5 of them. If we do 9 choose 14, we get a total of 2,002 possibilities. So as I divide these two, I end up with a probability of 0.0629. Okay, what's the probability that they will all be administrators? So this one, we're saying, okay, well, the bottom number should still be the same. We still got a possibility of like 2,002 possible outcomes from all 14 people that are being represented here. But if I want to take 5, there's 5 total administrators, and I want to choose them all to be administrators, there's 5 as well, that actually only equals 1. So 1 out of 2,002 is 0.0005. Okay, what is the probability that there will be 2 administrative assistants and 3 administrators? This one's going to have a little bit of a combination, right? We got to first figure out the 2 administrative assistants and then the 3 administrators. So 2 administrative assistants, there is a total of 9 administrative assistants, and we're choosing 2 of them. Whereas with the administrators, there's 5, and we're choosing 3 of them. So we get a total of 36 different ways we can choose an administrative assistant and 10 ways we can choose an administrator. But we want the combinations of both of those together. So think back to like our and or lesson. What do you think we're going to do? Are we adding or multiplying these 2 ways? In this case, we do end up multiplying these 2 ways to say there's a total of 360 ways that we can choose 2 administrative assistants and 3 administrators. Once again, it's that 360 out of the 2,002, so we end up with 0.1798. Okay, just for kicks, let's do this one last one. So, suppose you like a compact disc CD that you purchased has 17 tracks. After listening to the CD, you decide you like 6 of them. And the random feature in your CD player will play the 17 songs once in random order. Find the probability that among the first 5 songs you played, you like 2 of them. So we're saying, okay, well, you like 6 of the songs, right? And you want to just have 2 of them that come up. So doesn't matter the order they come in, no, so we're doing a combination, you end up liking 15. Okay, but out of 5 songs, you can also not like the other 3, right? So there's 3 that you don't like. And how many of them don't you like? There's 11 total that you don't like. So there's 165 ways, when we do 11, choose 3, that you can find ones you don't like. So if we want to get exactly 2 that you like, and then kind of 3 that you don't like, well, we got 15 orders that we can like, and we got 165 that we don't like. So we take those and we multiply those probabilities together to say, hey, there's a total of, I think it's 2,475 ways to get exactly 2 songs that you do not like. But how many total ways possible? So the total ways possible is 17, and we're choosing 5 of them. So if I take my 17, choose 5, then we end up with, there's a total of 1,688 songs possible. So the last step here is to take the total ways we can like just 2 of them and divide it by the total ways possible. So we end up with 0.4, like a 40% chance. Probability that you will like 2 of them. If you want to like all 5 of them, then we just are just choosing out of the 6 that we like, and we're choosing 5 of them. It ends up that there's 6 different ways we can get that. So we do the 6 out of the 6,188. Notice your calculator gives you something weird. I mentioned this slightly before. You get 9.696 e to the negative 4th. This e to the negative 4 is scientific notation to say, hey, move your decimal 4 places to the left. So it really represents 0.00099696 as your percent. All right. Okay, it's your responsibility now to go and finish that 5.4/5 homework.